Okay, so today I want to go over anti-differentiation, and I want to go over just, there are a whole slew of anti-differentiation rules, just like there are rules for derivatives. We're just going kind of backwards. So I want to go over just a few things that are basic, especially how they have to deal with powers and exponentials. So we're going to take a look at these two topics primarily and look at how do we take the antiderivative. So what we're going to do is we're going to look at a few examples today. So first thing I want to mention is that we have a notation for antidifferentiation. It's a symbol, looks like this. It's called an integrand. And we want to actually, this symbol is called an integral sign. And whatever's inside, usually it's a function, is called the integrand. So we normally represent an antiderivative as the integral of some function f of x. This is actually called an indefinite integral. We always want to know what, with respect to what value, with respect to what variable are we taking the integral. So we denote that by writing a dx. So the proper notation is the integral of f of x dx. And we normally write that as is equal to big F. I don't know why they use that notation, but we use it often, plus c. And so just to give you a little bit of, just to think about it this way, let's say we had 2x. If I took the antiderivative, then we would think that using the power rule, let's just go backwards. We know that if we had x squared, the derivative of x squared is 2x. But the derivative of x squared plus 3 is also 2x. And the derivative of x squared plus 100 is also 2x. So you notice here that we can add any constant to x squared, and when we take the derivative, we're going to end up with 2x. So if I was going to take the integral of 2x dx, I'm going to end up with the antiderivative. So I'm going to end up with x squared. Means if I took this derivative, I would get this function. So it's like going in reverse. So I take the derivative of x squared and I get 2x. However, I can add any constant to that. And if I take the derivative, I'm going to get 2x. In fact, what happens is whenever I take what's called an indefinite integral, I'm going to need to include this constant because every time I take a derivative of a constant, I have 0. And I'm going to end up with this function in here. So that's one of the most important things here is that you add your plus c when you're taking an indefinite integral. And we'll get to what a definite integral is later on. But today we're just going to look at these right now. So we've got something called a power rule for indefinite integrals. Now, if you remember, the power rule for derivatives is we would take this number, multiply it in, and subtract 1. Well, now we're going to do kind of like the opposite of all of that. So instead of multiplying, we're going to divide, and we're going, instead of subtracting 1, we're going to add 1. So if I use the power rule for this one here for integration, I would take this here, 2x, and I would add 1 to the power. The power here is 1, so I'm going to add 1 to the power, which is 2. Then I'm going to take this number, and I'm going to divide the entire thing by that. Okay, well, obviously the 2 and the 2, they simplify, and we get our antiderivative. So in general terms, we have a rule that we could use, and it's called the power formula. So the power formula, or the power rule for integration, is the integral of x to the n dx is equal to x to the n plus 1. So we're going to add 1 to the power and then divide by n plus 1. And of course, always add c. Now, just to make a long story short, we can add or subtract all integrals. So let's do an example here. So if I have the integral of the square root of x plus x cubed dx, I'm going to want to change this x squared to x to the 1/2 so that I have powers. Since I have a plus, I can add these two different integrals. If I wanted to, I can separate the two into two integrals. But just for simplicity's sake, I'll just do the power rule for both of these. So the power rule says I'm going to add 1 to the exponent, divide by that number. So 1 plus 1/2 is 3/2. So we're going to x to the 3/2 divided by 3/2. Plus, we're going to add 1 to this exponent, x to the 4th divided by 4, and plus